In this video, we're going to be talking about solving absolute value equations. So to first start, let's talk about absolute values. If I have an absolute value, it represents a distance. How many units am I away from 0? So if I have the absolute value of -3, well, that's 3 units away from 0. If I have the absolute value of 3, absolute value does not mean opposite, it means distance. The distance that 3 is from 0 would still be 3 units. So we can see here that I have a +3 and -3 giving me the same solution. So when we go to look at an equation, say absolute value of x equals a number, that will have 2 solutions, because I could have a +7, which when I take the absolute value would give me 7, so that would make that true. I could plug in -7 for x, and then when I take the absolute value, I would get +7, right? So I can have positive and negative values for x, but the absolute value itself will always, when I take it, become positive, because it gives us the distance. So when we go to solve these absolute values, we have to think of the positive and negative solutions. The first step should always be to isolate the absolute value, though. You can't set it to positive and negative until you've isolated it. It's the absolute value itself that can have positive and negative solutions inside the absolute value. So, looking at this first example here, I need to get this absolute value all by itself before I do anything else. So I'm going to subtract 9 from both sides. And the reason we do this instead of trying to combine these two here, which is what I see a lot, is that we have to undo the order of operations, right? So the order of operations says this: take 9, subtract 2 times that absolute value. So I can't combine it with the subtraction. I have to undo times with divide. So I can't do that. You should not combine the 9 and the 2. You have to get rid of the 9 by undoing the operation that was done. This is a +9. I'm going to subtract it away. So now I have -2, remember it's times that absolute value of x equaling -10. Then I'm going to undo this multiplication with division on both sides of my equation. And a negative divided by negative makes a positive. So now I have an absolute value equaling the number. I've isolated that absolute value. That's always a step 1. Then I have to set that equal to the positive and negative. So it doesn't change the sign inside the absolute value. It just says what's in there, so whatever's inside, could be +5 or could be -5. And since x was all alone in here, that's all I have to do. That is the solution. And then of course we could check it by plugging it back into the original and making sure we end up with a true statement. Let's look at the one below. On the left hand side, the absolute value is already isolated, so I don't have to worry about that. But now I'm going to take everything inside, so x divided by 3 plus 4, so that whole quantity could equal 1, or that whole quantity could equal -1. Again, it's not saying the absolute value equals -1, it's saying what's inside could equal -1, because then I would have to take the absolute value of that -1 and it would end up being +1. So now I need to solve these individually. So I subtract 4, same thing here. I now have x divided by 3 equals a -3, and x divided by 3 equals a -5. And then I have to undo this division with multiplication. I'm going to multiply both sides by 3. Those divide out. I have x equals -9. These divide out, and now I have x equals a -15. So it's also important to note that you can't just solve one. So if you get one solution and say, oh, it's 5, and then -5 must be the other one. Because that didn't happen here, right? I didn't get -9 and +9. I got -9 and -15. So don't just find one answer and then do the opposite. You have to solve them separately, right? Setting it equal to the positive solution and the negative solution. Again, representing what could end up inside this absolute value. Let's look at one more here. Alright, this one, the absolute value is already isolated. So again, I don't have to do anything here. It's already set alone on one side. I have an absolute value equals -3. Now I actually don't have to do any work here if I stop and I think about it. When I take the absolute value, no matter what's inside, if I had -52, I'm going to get 52. Right? That the distance from 0 would be 52 units. If I said the absolute value of 3/2, the distance would be positive 3/2. So whatever is in here, no matter what x is, when I take the absolute value, I'm going to get a positive number. Right? X could be -1,000,000. But when I simplify this and then take the absolute value, even if it was -1,000,000, the absolute value of -1,000,000 would be positive 1,000,000. I'm going to end up with a positive number on the left. Can that ever equal a negative number on the right? So the absolute value will always be positive. It can never equal a negative number. This can never happen. It doesn't matter what x is, this will never work. So this one has no solution. Absolute values do not equal negative numbers. Now that doesn't mean x can't be negative, right? We already found that x itself could be negative. But once you take the absolute value, it cannot equal a negative number. What's inside can be negative, but what it equals cannot. Why don't you try the ones on the right? Alright, here we are at this example. Remember, when we're solving an absolute value equation, our first step is to isolate the absolute value. I need to get this absolute value all by itself. So anything outside of it on the same side of the equation needs to be moved. So I undo add and subtract first. So I start by adding 4 to both sides. And I get positive 21. And then we undo this multiplication with division. This divides out. And we have the absolute value of 2x plus 3 equals 7. Now that I have the absolute value all isolated, then I can set what's inside the absolute value. So that 2x plus 3, it could equal 7. Or what's inside that absolute value could be -7, right? If I ended up with -7 inside here, I would take the absolute value and equals a positive 7. So, now we have our two equations. We solve them separately. I subtract 3. Notice we end up doing the same steps, but we will get different values. So 7 minus 3 is 4. Over here, -7 minus 3 is -10. So already we're different. I undo that multiplication with division, and x equals positive 2. Or -10 divided by 2 is -5. So x could be positive 2 or -5. Let's go ahead and check one of these. You should always be checking your solutions, all of them, but I'm just going to show you with one. If I wanted to check that 2, or actually let's do the negative one. Sometimes students don't think that x itself can be negative, and it can. So I'm plugging it in for x. So 2 times a negative 5 plus 3. I'm running out of room. Alright, so inside the absolute value, we would do the multiplication first. So 2 times a negative 5 would be negative 10. And add. So negative 10 plus 3 is negative 7. And then the absolute value of negative 7 would be positive 7. And remember, this 3 next to the absolute value here is multiply. So this is still multiply. And I do 3 times 7 to get 21. Subtract 4 and get 17, which is what it needed to equal. So you can always plug it back in and check to make sure you did it right. Alright, let's look at these two here on the right. On this top one, 4 minus 3, this is times the absolute value of x minus 6 equals 7. Again, do not try to add those or subtract them. You cannot start with 4 minus 3 because it is attached to the absolute value with multiplication. So I have to start by getting rid of the 4 and subtracting it from both sides. Now I have negative 3 times the absolute value of x minus 6 equals 7 minus 4 is 3. So now I want to undo this multiply with division. I'll start by dividing by negative 3, divide by negative 3, and x minus 6, that absolute value is equal to negative 1. So again, the first step is always isolate the absolute value. Now that I have this absolute value alone, I can see it's equal to a negative number. The left-hand side is always going to produce a positive number, right? The absolute value of anything is going to end up positive. The right-hand side gives me a negative number. These two things can never be equal. There is no solution here. Alright, and then if you happen to solve this, if you forgot that this couldn't happen, and you solved it, checking would show you that it doesn't work, right? So if you had solved this and checked, you would see that it didn't work out. There is no solution. So even if you can't remember, if you're always checking your work, then you'll know whether or not it's a no solution or not. Alright, this last one here. Now this looks like an absolute value equal to a negative number. And you might try to stop and say, oh, there is no solution, I don't have to keep going. However, the absolute value here is not isolated, so you can't stop. So this is negative 4 times that absolute value. If I divide both sides by negative 4, the absolute value is actually equal to a negative divided by negative, which is a positive. So again, that's why it's so important that you isolate your absolute value first and then solve. So now that I have my absolute value equal to 5, I know what's inside the absolute value. Again, I'm not changing anything here. It could equal 5, or that whole quantity inside the absolute value could equal negative 5. I need to solve these. I'm going to start by multiplying both sides by 2. Those divide out. And x plus 3 equals 10. Or over here, I have x plus 3 equals negative 10. Not quite done. I need to subtract 3 from everything. And x equals 10 minus 3, which is positive 7. Or negative 10 minus 3, which is negative 13. Again, you can't just solve one. It's not 7 and negative 7, it's 7 and negative 13. So you need to solve them individually.